Hi, so in this week I wanted to talk a bit about the project that I'm working on. So this is a personal project, it's not a work one, but it's sort of inspired by some of the problems that I encounter at work. And I've got a little diagram on the screen here, which you can see it's sort of the main context of what a database management system would often look like. Um, and so from a programming perspective, a lot of the time this stuff is opaque to us. We deal with the database via SQL, and we're um, in the business of developing this application logic and sometimes some object abstractions to assist with how we make our programs work. And what I am hoping to do as a part of this project is to experiment with how we can move this object abstraction inside of the DB service. Now, it's very, very early days for me. I'm just starting basics. So what we're looking at here is, imagine we have an application, it calls into SQL, and actually maybe once I've done this, it will use a different mechanism to talk to the object abstraction instead of the SQL front end, but who knows. There's a query optimizer in here, which for now I'm thinking of as sort of optional, but that I might build one as part of this project to understand how to make it work. We have a table abstraction that sits on top of all of those things, and that's like the rows and columns that you're used to using schemas of abstractions, of databases rather. And then inside of the database, what makes the magic happen is the transaction log and how we write to the transaction log, how we write records and how they're indexed, how you search for individual values in the records, how they're organized. Now, most modern databases have a mechanism for looking up that data and inserting data less expensive, and often that's implemented as a BTree. And that's sort of what I wanted to talk you through today. I've got the startings of an index mechanism in the form of a BTree. So I've started implementing sort of a file storage mechanism. The idea of separating it from the indexes and the transaction log themselves is that actually we might want to choose how these are differently sort of partitioned within the application. We might want to combine them, and my plan is to combine those things together. So that's I'm really going to be showing you a little bit of this and a little bit of how I expect this to hang together. Again, it's very early days, so I haven't got a full index yet. I've just got a BTree implementation and not even a full implementation yet. It's just an insert and a search. But I'm going to show you some code and we can talk through it. So the first part that I talked about there is the random access file. So I wanted to come up with an abstraction for how we read and write data. And you'll see in this abstraction we've got a write data. You go to an offset in the file, and then there'll be a blob of data that we write, which will have a size. And then you can do the same sort of thing. You go to an offset, you read a blob of data, which again has a size. And then I've got all of these helper methods here to get data within the file. And then I've also got some extra helper methods here that just work on memory so that you can convert different integer types into the blob that you would want to store. So I'm going to show you that, and I'm going to publish this on GitHub as well, so I don't feel like you have to do screenshots to get what's going on here. I'm just going to show you this one. So really it's just a very simple file mechanism. You read the data and then you convert it to the data type, which then is passed out via an out variable. And that, they're really all very similar. These are the memory-based ones, so we're basically grabbing a byte, shifting it, grabbing another byte, shifting it. The file itself, here is my my plain one. This, there's not much to it, and actually this one in particular, I asked ChatGPT to write this, and it did a pretty good job. I've also tried to use it for the BTree as well, and I was really pretty unhappy with the results, so I've hand-coded most of the BTree stuff, but it did a pretty good job of this one. In particular, this particular mechanism to open or create a file is a pretty painful one in C++, and it gave a pretty good answer to how to make that work. So getting the file size, we seek to the end, we get the position, writing a blob of data, okay, we seek to our offset, we check it's good, we write the data to the file, and then we return whether or not it's good. And reading data, we seek P and seek G for setting, for writing and reading the file. So that's the first block that I showed you here. That's the file storage. I really don't expect to do much more work on that. It's almost complete. I have been sort of thinking about whether I need to pass the offset in every time that I do something. Open to changing that, not sure. Okay. And then, so I had 2 goes at doing the BTree, and if you're looking at the source code on GitHub, you'll see BTree and logging BTree. Logging BTree is the one that I'm actually using, and I'm thinking of getting rid of the BTree one. The idea with this is that I want to have a BTree that you have the choice of whether or not, when you write new nodes into the BTree or update nodes that you are able to copy on write, and that preserves the history. But I also want to be able to contain all of the writes to a single transaction. So if you're in the middle of a transaction and you changed a particular record, then I want to be able to update the records in that transaction and the nodes in that transaction. So that's sort of where things got a little bit complicated and where things are starting to get hard. But I'm working on it, and once you get something working, you can then get the next little bit working. I think the software in general is best. Problem solving in software is best done by breaking problems down into smaller and smaller problems, and eventually you get to the primitive problems like is this a 1 or a 0, which the computer's really good at, and then you can start building up your solutions from those smaller problem solvers. So we've got a part I'm working on, and it's going to change. Right, so scrolling right to the top, I've got, and actually let's head back out to the header file. I've got a node data structure called variable BTree node. I intended this to be a variable size, but at present, because I'm updating the nodes, you need to know if you're going to update a node, particularly if you're going to update how many items are in a node, you need to know that that node has a predictable size, because if you want to change the size of a node that you've already written to disk, then it'll start potentially overlapping the next node, and you'll overwrite it, which you don't want to do. So it's called a variable BTree node, but in this implementation, it's still not is not variable. They're all hard-coded sizes. I've got a few sort of parameters, and this is just to make creating the BTree itself a little bit tidier. So we've got a key size, a value size, the maximum number of values, which I'm hard coding, and whether or not to use copy on write, and actually only false is implemented at present. And then I've got a bunch of methods, but the ones I want to talk about today are find key and insert key and data, which is the ones that I've implemented. So logging BTree. So reading a node basically involves getting all of the properties of the node, and then the data. Writing a node is basically the same thing in reverse. You write all of the properties, the flags, the key size, the value count. And I'm thinking of putting some aggregates in here, things that will be helpful for the query optimizer later. Things like the number of subnodes, the number of entries, perhaps even sort of statistics about how many, not sure, but I'm thinking of augmenting this node data structure at the moment. Obviously compatibility will be a problem if I change the data structure, but I'm not planning on releasing this, and really please don't use it in production because it's definitely not ready. And this is what I was talking about with not copy on write. In this case, it's writing an empty space at the end of the node. This is getting the size of the node, which depends on whether or not we're using copy on write, as we described before. Once you've loaded the node, you can get so you've got all of the keys and all of the data, and they're at the moment I've got them interlaced. So you've got the key, data, key, data, key, data, and so getting a key at n or a value at n just involves seeking to the right position in the blob and getting the data out. I've got a mechanism because we want to sort the keys in the BTree, you want to be able to identify whether one key is smaller or larger than the other. And actually, I think that C++ has a pretty good mechanism for that, which I'm sort of thinking about replacing this with. But really, this one just goes through all of the bytes of the key, and if one is bigger than the other, then it will choose that one. So finding a key involves looking at an individual node, seeking, and here it's going through each of the values in each of the keys in the BTree node, and comparing to see. So the comparison might be less than 0. It might be, and that's Copilot. It might be go away. It might be equal to 0, which means that we've found a key. It might be less than 0, in which case we've gone past the key and it didn't exist. Or it might be greater than 0, in which case we might need to keep seeking. Then eventually we find a key, and if it's a leaf, we might also want to get the value. Otherwise, we might need to read into the next node. I'm using the node that I've got on the stack here to read the node, so it's just not keeping so many nodes in memory, and that's probably fine for a find. But I'm doing different things for for the insert. For the insert, okay, I've got this method here called insert recursive, which is really doing all of the work, which I'll go and find now. Again, we are finding the key if it exists, and then depending on if it is a leaf node or a branch node, we'll do different things. If we found the spot, and actually currently if it finds the key, I treat that as an error. Trying to decide on what to do with inserts and updates, but at the moment it has to be a pure insert, and if it finds the key, that's a problem. So it hasn't found the key and it needs to insert one, or it's a branch, and if it's found the key or it's found a space where the key should be, then it's going to recurse down to the next node until it gets to a leaf where it's going to insert it, and then on the way back up it will decide for each node in the hierarchy whether or not it needs to split, and that decision is based on whether or not it's exceeded the number of items that are in the BTree. So if an insert's required, it will decide whether or not there are splits needed, and if a split's needed, it will create a new second node and move the data from one node, half the data from one node to the next. If it is able to do a simple insert, it will just insert the data, and then it will have to filter that information back up the tree. And each layer of the tree, it may have to decide whether or not it needs to insert just a value or whether it will need to split all the way up until it gets out at the top of the, so we're going back to the public function here. It gets all the way out to the top of the tree, and if it had to split, then it needs to create a new root, which is what it's doing here. So that's a little bit of a tour of what I've been up to recently. I hope that wasn't too complicated, but I'm happy to answer any questions if you have any. As ever, hit me up on email, find me on GitHub, I'm on Threads, I'm on Twitter. Let me know. Thanks for watching.